First, open the file, download it from FOL, Lab03 Expression _1, and then save it as with the initial. You're going to use your own initial here. Then let's start with a sketch. Make sure your x direction is perpendicular to xy plane, and then x red arrow pointing to x positive direction, and the green arrow pointing to y positive direction. Hit OK. Now we're going to start with two perpendicular line as the reference line. So create a line using the origin, and then roughly 50, and then use sketch origin, undo it, use 0, and roughly 50. Because we're going to use this as a reference line, so we're going to right click it and use this convert to reference. You can see it becomes dash line, and do the same with the vertical line. Now we're going to create a polygon with 6 sides. You can see here, use a point, make sure select point. We're going to use a center line, center point, and then make sure the number of sides is 6. Specify a point. You would like to specify a point on this vertical line. Okay, now close it. Then we're going to dimension. So make sure this size from here to here is 14. So we're going to use rapid dimension. Select the reference, which is the vertical line or y-axis, and then select the line or middle line or end line or sketch, each of them, and you can see we're going to input 14. Okay, then you can use the fit to zoom in. Now the head is determined. Now we are going to create the circle, represent the outer diameter of the thread. So the same origin, and then put it here. You can see the diameter of this hole is being given here. We're going to use 12 here. Hit OK. Then this is the head, and here's the thread out diameter. Exit or finish sketch, Save the file and make it in orientation. Now we are going to use Extrude to create our bolt. Extrude. It asks you to input the curve for extrusion, so we are going to use this outside. Make sure you choose connected curve and then select one of this line. Then the outside will be given, and make sure you're going to extrude this one in the negative Z direction. So if necessary, click this. We're going to input this as 6. Preview. So you can see here it is going to positive. So we would like to go to negative. So direction will be negative. You can see when we click isometric view, we can see the body is extruded under the sketch. We're going to hit apply. When you hit apply, then the feature you created will be accepted and shown in the part navigator. And in the meantime, this command dialog box is still showing here. Right? So what we're going to do, we're going to create this thread. So we're going to select this time we're going to select a single curve. Okay, and then it is positive. If it's necessary, you're going to change the vector direction, reverse direction, right? So this is a positive, and we would like to put 55, and then we're going to preview. Isometric view. If it looks good, then we click OK to apply and close the dialog box. OK means apply and close the dialog box. You can see we have extrude here and extrude here. In the meantime, by default, when you extrude this cylinder, it automatically asks you to unite this to the head. We just use this setting. And if you choose none, it will not be united, and you get two solid body. We accept this, so you would see a solid body. So it's only one single solid body. You should only see one single solid body. Save the file. Before that, we hide the sketch, and you only see this solid. We also hide this datum coordinate system, and then use isometric view to bring it here. Now we save it. Now we can see when we create a sketch, extrude, and this extrude cylinder, we input some values here. Those values actually stored in expression. So if we go to tools, click expression, then expression dialog box come out, and we can see for sketches, all expression, by default all expression are showing, and here shows active group only. And we will learn this in the future, and you can see here, so we have many expressions being created here, right? So if we click show, you can see user-defined expression, named expression, unused expression, feature expression, measurement expression, attribute expression, interpart expression, or expression. So by default, all expression is being chosen, and you will see everything. Let's look at user-defined expression for this moment. We don't have any user-defined expression yet. However, if we look at the feature expression, because we haven't choose any feature yet. So if we choose any of this feature, for example, datum coordinate system, we don't see any being shown here. If we select sketch, you can see we input the polygons parameter to define the hexagon. So we can see P6, 14 is here. You may have different P value, P6, P5, or anything, but you can see here sketch, perpendicular dimension between line 2 and line 3. In your case, maybe a different one, but you can see value 14. This is used to define our hexagon size. And here, you can see P7, in my case, is 12. It says diameter, dimension of arc. So this defines the value of the circle, which is used to get this cylinder. All right. So if we click extrude, then you can see the beginning, start limit, and the end limit is shown here. And this is the cylinder. You can see also shows the start limit and the end limit of the cylinder. So if we get back to all expression, then you can see those. Okay, so the source tells us which dimension is associated to which come from, which feature or come from where. So let's hit OK, and we are going to create another feature, which is a thread. Go to more, go to home tab, and go to more. You can see thread here. If you cannot find a thread, what you're going to do, I leave this question for yourself. So thread, we can create a symbolic thread or detailed thread. We're going to create detailed thread for this case, in this case, and you can examine symbolic thread by yourself to see what you can do. What's the parameter you are going to put here, and so on. So we're going to use detailed, and then if you look at the the bottom, you can see select a cylindric face to start create thread. So we're going to create the surface of the cylinder, and then you can see because this cylinder is 12 millimeter, so the major diameter is being input as 12 millimeter automatically. And then you can see we have input minor diameter. You can specify, but the system have some value being stored, so they use those tables to fit those parameters here. You can see length is 55, which is the total length of the cylinder. Pitch 1.75, angle 60 degree. So we're going to change this to 20 and leave the rest as default and hit OK. make sure check your parameters. So major diameter 12, minor diameter 10.25, length 20 millimeter, pitch 1.75 millimeter, and angle 60 degree. Hit OK. Now you can see the thread is being created. At this point, we're going to save our file. Now let's look at those expressions again. You can see there are some expression being added. So you can see, so thread, 5 parameters being added. Let's say look at the feature expression and select thread. You can see we have P12 and tier P16. In my case, you may have different ones. So what we're going to do, we're going to give the name for those expressions. Those expressions are created by the system. So you can see all these expressions created by system are given name P something. Okay, so what we're going to do, we're going to rename. Instead of P here, we're going to see, we're going to give the name for this parameters or expressions. First, let's look at this one, this major diameter. We're going to give a name. You can edit, give the name, thread, major diameter, major diameter. Hit OK. Now you can see a new name is assigned here. Let's apply. Feature. Okay, it's updated. The name is being updated. The next one, we're going to give thread minor diameter. And then for the thread angle, give thread angle and GLE. And then for thread pitch, we're going to use thread pitch, thread pitch. And here is the thread length, thread. Okay, let's hit apply. Good. In the meantime, we also want to give the name for the sketches. So, feature, sketch. So this one is the head. The size of the, determine the size of the polygon. So we're going to give head size. And then this one we're going to give thread size, or both sides. We use thread size in this case, and hit apply. Now you may notice this thread size equal to major diameter, because when we look at when we create the thread using this command, the default input is being the diameter of the cylinder we chosen, and the cylinder is determined by this sketch circle, right? So this is the expression we created. Let's look at something else. So if we click named expression, we should have those expressions change the name displayed here, and all expressions. So then we see all expressions, and those expressions does not we don't change those expression names, we just leave it here. Probably we can also look at this one, because this one is the total length of the total length of the boat. So we put boat length here, hit apply, boat length, hit OK. Now you can see we don't have any changes on our feature or on our 3D model. However, the expression behind it is being changed with some meaningful name. Now we're going to look at user expression. You can also see user expressions here. So we will define those expressions, so we will be able to use those user-defined expressions to control our thread. Let's go to Tools, Expression, open the Expression dialog box. This time we're going to choose user-defined expression. You can see we don't have any user-defined expression being given here yet. So we're going to create something. Double click the empty name and then say, this time we're going to give the name input thread angle, thread, say bolt angle, so we don't have confusing with the other expression just to create it for the thread. Angle. So we are going to say this angle will be a number, type will be number, dimension will be angle, and it is degree. So we are going to put 60 formula in the formula, and then once you hit OK or enter, then you can see the value is 60, and let's hit apply. If you hit apply, then what's happening is you will be able to close it and then open it again. Then it's being saved in this file. But remember, you haven't saved your file yet. So if you close this one without save, what's happening is the expression you just created here will not be stored in on your disk. So you'd better to save it for now. Okay, then you can see user expression. You may not be able to see your user expression in the Part Navigator, but if you click and expand it, you will be able to see that being listed here. So let's keep doing. We are going to create other expressions. Next one, input bolt length. So this one will be, let's say, 16 millimeter. You can see by default is the number, length, and millimeter, right? So we're going to put some comments here so to remind me what is this for, because we have so many lengths here. So this will be the total length of the bolt. The total length of the bolt. So you can see it here. The total length of the bolt. Okay, you can use this bar to scroll from left to left. Okay, so we're going to create a new one, new expression. This one will input bolt thread length. Thread length. So this one we're going to give at this point I'm going to give 20, and then input bolt major diameter. We're going to give 11 millimeter. Make sure those are millimeter lengths, right? So, and then input bolt pitch. We're going to give 1 here, millimeter, and then we're going to give input bolt minor diameter. So this time we're going to give a formula here. Before we do that, let's apply so the system have all this parameter being given. So now you can see input bolt diameter minor diameter is 0. So I'm going to give a formula here. So let this equal to input bolt major diameter, which you can use arrow, up arrow and down arrow to select those. If I hit OK, you can see it will be 11, right? So, but this is not what we want. We would like to use major diameter minus pitch. Oh. So input major diameter minus input pitch. Let's hit apply. Now you can see it will be determined by the input major diameter and input pitch. Now you can see 11 minus 11, 11 minus 1 equal to 10 millimeter here. This is the, I'm going to create one more. This will be, say, input bolt thread factor. I'm going to use this one as a number also, but I want to create a constant. Let's say this equals 2. Hit apply. Now we have a constant, right? So we would like to make the thread length is associated of my major diameter and this thread factor. So I would like to give a formula input bolt major diameter times input bolt thread factor. So we're supposed to get 22. So let's apply. You can see 22 is being given here, right? Okay. We create all the user-defined diameter, and you can see user-defined diameter, user-defined expression. Those user-defined expressions are listed in the part navigator. You can see that. Let's hit OK for now, and then save our file. So everything you just modified will be saved on your disk. With all this user-defined expression being defined, then we can use them to control our features. So how to do that? Let's look at this expression dialog box. You can see here. So if we look at unused expression, we can see those expressions are not being used, right? So, and now let's look at all expressions. So those named expression, those user-defined expression, named expression, right, is not those system is not the expression named by the system, right? So if we look at, so those are not named expressions. All right, so those expression we just created. So how we can use them to control our feature? So what I can do here, I can say this thread angle equal to bolt angle, but for now I just leave it here. So what is thread length? Major diameter, minor diameter, pitch, size, right? So what we can do here, we can just simply say the angle equal to input bolt angle, input bolt angle. You can see this symbol means if we apply, then this value will be applied to here. We will not see anything, but the length, thread length, we're going to use input thread length here, input bolt thread length here. You can see. If you hit OK, then you can see. If you update, it will become 22, right? So let me apply. You can see, right? So this value is being updated. Okay, so thread major diameter, we can use input major diameter, and this one, okay, and then this one I'm going to edit this. If you edit it, edit dialog box will appear here, right? So input bolt minor diameter. So hit OK. You can see, right? So pitch again, pitch. If you input pitch, hit OK. Now I'm going to apply it. So, and one more. 1, 2, 3, 4, 5. So we'll get 5 updated. Okay, there's one more thing here. We would like to make a thread size, which is the sketch, the circle we created in the sketch. We would like to, you can see here, if we applied 11 here, what's happening here is we get something which is strange. So why is that? Because the cylinder is actually 12 millimeter in diameter, and the thread you created, its major diameter is 11 now. So we must make this equal, right? We must make this equal. So this is supposed to be input bolt diameter as well. So the cylinder we created is the same. This cylinder is the same as the major diameter. Okay, this is what we have. We're done the formula of this system import. So if you look at here, feature diameter, so added the threads. So you can see here, each value is associated to some input, right? Expression, user-defined expression. So, and this one is actually the same as the extrude. Okay, same as the extruded outside diameter, and which is also, if we look at, let's say, edit with rollback, and you can see here, this size is equal to both major diameter instead of value you just input here. So a formula is being given. Now head size is also a named expression. So let's look at this one. If we can change something here, so let's say we're going to make a major diameter equal 10, and the pitch we would like to make it 0.75. You can see we get a very fine thread, and also we can change the thread factor to be 4. What's happening? Then we get different lengths of the thread. So you can use this parameter, or say user-defined expression, to assign different value or change your 3D model very easily. Save your file, and then you're ready to upload this to your FOL.